I know we have covered some logistic regression technique in the past and some data visualization concepts. This particular exercise is a blend of some of the modeling techniques and also a little bit of data visualization, because we want to know how the decision tree is functioning and how we are able to change the parameters in the decision tree to enhance the accuracy of the model. Without any further delay, let's get started. I'm going to select the data set as usual from Kaggle. I want to select this particular data set called Adult Income Prediction Classification. Let's get started with the notebook here and label this Decision Tree Classifier Income Disparity. Okay, let's label that and run this quick snippet of code and get the file path, which we are going to use it in the subsequent steps for the decision tree modeling technique. While that is running, okay, we have the data set here. Let's select that and start a new window. We are going to import our usual libraries. Import matplotlib because we want to visualize the decision tree towards the end. Import. We want to get the decision tree classifier from scikit-learn model selection for splitting the data. Plain test split. We want to get from scikit-learn the tree. We are going to get the decision tree classifier today. Also, we need to get the plot tree, which is to visualize the decision tree. And what else do we need? That's pretty much it. Okay, we do need to understand the model statistics once the decision tree technique is built to understand the accuracy. So we are going to get some from scikit-learn metrics. We are going to import classification report and confusion metrics. Okay, we have all the information we need. Now we are going to define the data frame. We'll call this income and pd.read csv. Copy the file path here. And we get a quick snapshot of what the data looks like. So we're going to get a sense of what the data looks like at a high level. So we're going to do that. Okay, we have several pieces of information here. We have age, which is great information to have. The work class, the salary, the value of the salary, I believe that's what this column represents. Education number of years, I believe the education was. Marital status, occupation, relationship. Talks about not in family husband, not in family wife, husband. So it's pretty much very high correlated to the sex, male or female looks like. The race, white, black, Asian, Hispanic, etc. Sex again, which is going to be a good indicator of male or female. Capital gain, capital loss. I'm not 100% sure what this is. This is probably tied to the income as well. Hours per work, country, and salary. Okay, so that's the high level. And today we are going to get a sense of this extra window. We are trying to get a sense of disparity in salary based on the factors in the data set. So we're going to identify the disparity and which group has the highest disparity with the rest. We want to identify that pocket of people based on these different factors, the combination of these factors like work class, education, marital status, and country. We can add all of them and try and see which one is giving us the maximum disparity. Okay, so that's the hypothesis for today, and let's get started. Initially, we need to identify the x or independent variables, and y dependent variable. Variable, and we're going to define that. Select the trim. Since we're going to select multiple columns or multiple factors, I'm going to select age as one of the factor. Just type it here. And then we have education as the second factor we want to consider. See the influence on the salary disparity. And we also want to select the marital status. Then we can get the race there. We can get sex and the country. These are good variables to start with. Now let's select the y variable, which is the income and salary. We're going to select get the disparity of salary in the factors which are above, and see how that's going to split our decision tree here using the decision tree classifier technique. So we have all that. One thing to keep in mind here is, since these are categorical variables, we need to use one hot code encoding to establish variables that the model can understand as an input. Right? So that's what we're going to do. One hot encoding to convert the categorical variables for model training. Okay. So we're going to call this one x encoded is equal to pd dot get dummies. That is the library coming from pandas, and we have pd.dummies, and we are going to get the x variables and select all these columns essentially on the data frame. We just need to add one extra parameter here, drop first true. So we are able to get, you can see if this encode is working. And you can clearly see how the categorical variables are being converted, which the model can understand. Okay, let's try and run that real quick. Looks like there is an additional parenthesis which is not needed. So do it on this part. Okay, if you can see, it is breaking down. Well, the age is not really needed. It is a continuous variable, but for education, it's breaking down by education 11th, education until 12th, education 1st to 4th, and so on and so forth. And the education categories are very clearly defined. So, and similarly for country, and similarly for other categories which we need to input to the decision tree classifier. Okay. Now, after that step, we are going to select. Oh, we are going to split the dataset to train test samples. Okay. Now we have x train, x test, y train, y test equal to train test split x y test size is equal to, let's start with 0.2, 20% sample, and then depending on the accuracy of the model, we can come back and change the sample size. Here, one thing to keep in mind and change is we have created encoded variables as the dependent variables. We are going to change that to encoded, which is the new set of independent variables that we have created, which the model can understand better. Okay. Now we are going to define the parameters and select the model. Okay. In this step, we are going to say CLF into decision tree classifier minimum max depth. This is a parameter that we need to specify to keep the size of the decision tree manageable and understandable. for our analysis. So we'll start with the maximum depth of 3, and then we can certainly break it down into change these hyperparameters to fine-tune the accuracy of the decision tree, and also being able to understand and interpret how the decision tree is flowing and how the classification is being done. The other parameters which we can define, we can choose not to, are minimum sample split, and let's start with 2, and minimum samples leaf, which meaning how many leaves are we expecting when there is a classification being done from the roof node to a leaf node. How many? What is the minimum number of leaves you want the decision tree to split? I'm going to keep this as 2 also, and random state 42. It's just a norm, and there's no specific reason we can keep that as 60. Doesn't really hurt. So minimum sample split is 3, let's say, and max depth is 3. We can always come back and change these hyperparameters. Now we are going to say, train the decision tree, explain white train. Okay. Now the next step is going to be test the accuracy against the test sample we have carved out in the steps above. So we are going to call that y predict is equal to clf dot predict. We are going to predict the accuracy based on the test sample. The equation we have arrived, we have collected in the training exercise. We're going to test it against the test sample that we carved out to test the accuracy. Okay. Now we are going to evaluate and the model accuracy, which is model fit statistics. Okay. And we are going to call it print classification report. Okay, and then print classification. We have imported this in the beginning, right here. That's exactly what we're going to copy here, and say y test, y predict. That's how we are going to get the accuracy. And then we are going to also get more evaluation criteria in here. So import a certain matrix called accuracy score, which is going to help us understand the decision tree classifier at a much closer level. So we're going to define the accuracy as accuracy score. Let's copy this part. And you want the accuracy score again the same syntax. We want the accuracy score y test against y prediction. And accuracy all right, so we have everything what we need. Now the last step is visualize the decision tree that we have generated. Let's visualize the decision tree classifier. plt dot fit size. We have a standard fit size of 10:6. You can always increase the size depending on if you want a much bigger plot to visualize. If you want to copy it to some of the PowerPoint presentations, you can certainly do that. So we have imported this plot tree, which is used to visualize the decision tree here. So we're going to bring that and bring in the decision tree classifier that we defined earlier, get some of the features. And certainly always double check the syntax to make sure we are not very off with the syntax. There is a back and forth. Of course, there is no set way to get this right in the first instance. I would not believe that. So always welcome to go back and check. As long as the flow of logic and the training exercise and the hyperparameters are all intact and making sense, you can certainly go back and make edits. Okay, that's pretty much what we need. And then we are going to say, we have this beautiful chart which is clearly showing how the salary is being broken down based on these different factors that we have in the decision tree algorithm as features. This particular branch with Gini index of 0.469, which is supposedly the highest in this diagram, that this sample of 88 people have the highest disparity of salary, and you can find the second highest disparity, which is broken down by education, and the next highest disparity is broken down by age, and the next highest disparity is broken down by marital status. That's how I would read the decision tree. Of course, you can extend it to random forest and increase the accuracy and make it more robust for your specific use case. But that's all for now, and we'll catch up on our next journey in some more interesting exercises. Thank you.